Hello friends, my name is Sarthak Malik and welcome to our playlist of mastering machine learning from basics to advanced levels. Okay, and because this is our very first video, so in this video we'll be covering the very basic question that what is machine learning and how it works. Okay, and also we'll try to implement one of the machine learning model in this video itself. See, I'll just first of all, before starting this video, I'll just clarify you few things that this playlist is created not to teach anyone on or not to tell anyone about the theory of machine learning. uh, in fact, not just the theory. Obviously I will tell you the theory also, so just as to clear the concepts of machine learning so that you can implement it on any data set. But before going further, uh, there are many tutorials on YouTube that tells you about machine learning, AI. But this playlist is uh, created to ensure that whosoever watches this playlist is able to implement that implement any machine learning model. First of all, he should know, he will be in fact knowing about every machine learning model. He will be able to implement it in at any data set. He will be able to know what is uh, what are target, what are features, what is feature scaling, what is supervised, unsupervised, all those terms we have heard of. So basically I'm telling you all the program outcomes of this playlist. Okay, or I should say playlist outcomes. So so let's start without just wasting any time. Okay. um okay, what is machine learning? That was our first question. So one more thing, I'll also provide you with the notes and all the documents that I show you in every video. For example, if I show any document in this video, I'll be sharing it in the description and you can use that as a resource. So our very first question is basically, what is ML? We all just talk about ChatGPT, LLMs, LLPs, Gemini, Sora, Mid-Journey and all. We all say that, oh, it's AI. So AI is doing everything. AI is creating videos. AI is creating PPTs. We know about Gamma app. Like it create PPTs, documents. We know about ChatGPT. It it basically it can generate any type of text. It can generate codes. We all call it as AI, right? But many of us, we don't know the definition of it. Okay. So okay, if I start like if I visualize, let's just denote data science as DS and create some relations, right? So that we all can understand it easily. We all know what are relations, what are sets and all that. Okay. Data science is basically a field of study where we are able to read the data, we understand it, we are able to uh, create insights from it, we are able to manipulate it, delete, drop, create, add anything, and all of that stuff. Okay. So data, for example, if this is a set of data science, so there is a subset of data science that is called AI. Yeah, AI. So AI is a subset of data science. Okay. Okay, one more time. Data science is an ability, or it is a field of study where we are able to understand the data. Data science, the word obviously states that all the techniques, all the things behind the data, you are able to understand it, you're able to read it, you are able to modify it. So that comes all under data. Now what is AI? AI is basically any type of program uh, that acts that okay, let's change the color also. Any type of program that acts like human. It can be if else also. By writing if else, I mean that if there is a program, for example, marks generator. If marks are greater than 80, then grade is A. If marks are in between 60 to 70, then the grade is B. Oh, I've written it wrong. If the marks are greater than 60, less than 70, the grade is B. All that it's a basic program of if else condition. So it is acting like a human because it can tell you about the grades by looking just at the marks you provided, right? A human also does the same thing. You can provide marks and it will tell you the grade accordingly. So any type of program that acts like human is called artificial intelligence. That is AI basically, and it is a subfield, or you can call it as a subset of data science. Okay. Oh, sorry. I'll just take a screenshot of it so that I can share everything it with you. Okay. I'll just move ahead. So I was saying that AI, any program that acts like a human. Now, if I go more deeper into this AI, there is one more subset of it. Earlier, we saw that AI is a subset of data science. There is one more subset of artificial intelligence itself, and that is machine learning. Okay, one more time. Data science is the very first set. Everything comes under this. AI is the subset of data science, and under AI comes machine learning. Okay. Now, if I just tell you the theory, or if I say, if I just tell you in words what is machine learning, so it's very simple that. So, in words, machine learning is a field of study, okay, that gives the computer ability to learn without being explicitly programmed. Now, what does this line means? It means that you create a program and it learns itself by getting the data you provided, and without being explicitly programming it, or I should say without programming it again and again from outside. You just provide the data and then you don't have to program it again out from. Okay. So it will be able to generate insights or predict values or do whatever you want to do with the program. I mean, what the user wants to do with the program, it will do, but you don't need to program it. You just provide the data and it will learn. So machine learning is basically the ability of the computer through which it can learn, right? And after learning, it will do specific tasks that users asks from the computer to do. In general, the more opportunities you give a learning algorithm to learn, the better it will perform. Okay. So what does this line means? I'll just remove it. The more opportunities you give computer is a machine. The more opportunities you give a machine, the better it will perform. It means, okay, before telling you the exact meaning of that particular line, first I'll tell you one basic flow of how machine learning works. Okay, we first saw that what is machine learning. What is machine learning? Now we'll be seeing what how it works. So the very first step is knowing what to do. What to do? We opened our computer, we opened our compiler, then we also have a data set. Our boss says, our boss asks you to create a machine learning model and just predict the target variable x. Okay, you are asked to do that, and you just look upon the dataset and you start typing the program, but you don't know what to do. Okay, so the very first step is you should know that what I have to predict, what my boss is asking me, what are the features. Okay, so x is denoted, why I am writing target as x, feature is y. These are just variables, so you don't need to worry. Basically, in any data set, name, roll number, registration number, class, okay, in any data set, the thing or the value you want to predict, for example, I want to predict the okay, I'll just add one more column, marks column. Okay, if I 1 2 5 3 3.5, let's just say, name is A B C D, roll number is 1 2 3 4 101 102 103 104, and class is x x x x. Okay, so if I want to predict the marks of any person, and if I provide the roll number, name, and registration number, not registration number, if I registration also, and if I want to check what are the marks of that person, this is basic DBMS that I am teaching you right now, not ML, just to clarify you the basic terminology or basic workflow behind the machine learning, how it works. So basically you are fetching the detail of marks of that person, person, roll number and registration number you have provided. So x becomes marks that is dependent on values you provide. Okay, see, marks is obviously dependent because you are providing name, roll number and registration number by yourself. Marks will be changing every time you change the value of those three features or columns, right? One more thing, columns are also called features. You have to remember this thing. Columns are also called features. Okay, just move aside. Okay. Okay, so x was marks, it was dependent, and y was all those features which were independent, and also which were responsible to calculate the value of x. So every time there is a function f of y, okay, that is responsible to calculate the value of x. Okay, machine learning is all about maths. This is the very first thing you need to remember. and in every model there will be functions, there will be formulas, there will be maths, there will be statistics, probability and all that. So if you're good in maths, you will be good in machine learning also. So I was saying that there will be a function that will calculate the value of x, and where x will be dependent variable and y will be an independent variable. Okay, why independent and independent? Because x will be calculated based on the values of y. So y will be independent. You can choose y, but x will change according to the values of y. You can also change the variable names. It's not strict. It's not a strict rule that you have to denote dependent variable as x only. Okay. Moving further. Now let's just look upon what are the types of machine learning. No. We were at how machine learning works. Yes. So the first step was what to do. You should know the step 1, you should know the target variable, you should know the feature. Step 2, you should load the dataset obviously, but in the step 2 you should first of all process the data. You should first look upon the data that is provided to you. Process the data means if there is any missing data or the redundant values in the dataset, you should remove it first, because if you don't pre-process it before training the model, obviously the accuracy or results will not be that much good that you expect. Okay, so the step 3 will be that will be splitting. That will be splitting. Now what is splitting? I'll just move it a little bit down. So let's just change the color. Okay, that's okay. Splitting. You pre-process the data, you know about the target and feature. Okay, one more step below it. Choose the model. I forgot to write it, so sorry. Choose the model. This is the most crucial step, but we will be learning about this in further videos. I'll not talk about it today, because this is a very big topic. Obviously I'll tell you about this, but in this very first video we are just looking upon the basics. How, what and what is the basic workflow behind splitting the data. Why split the data? Because you'll train obviously, but after training the model, where you will test it? Now you'll say that I'll test it on the custom values that I will provide, but this is not how it works. After training the model, to achieve the best accuracy or to achieve the perfect accuracy, you should test it on the data set itself that you provided, and also you have to validate it, because if these two things are done using the data set on itself, then training will be more efficient. It will give more accurate results. That is true. Okay, moving further after splitting. I'm so sorry. I'll just tell you what is the best train, test, validate distribution in the dataset. So if you are provided with a dataset that is having 100 samples, basically 100 rows or records, or rows are also called records. So if you're given 100 samples, then the best practice of splitting the train test validate is 60% should be train, 20% should be test, 20% should be validate. Train, test, validate. This is the best practice to achieve the uh, perfect accuracy or the best results. Okay. The next step is obviously training. After splitting, train, and the last step will be testing the model. If the model is perfect according to your expectation, then you are good to go. Export it, go to your boss, say it, I've done it, and yeah. But what if your model is not as per your expectation? Then okay, if your model is good, you win, you did a good job. But if your model is not good and you're not getting uh, those expected results, then obviously there is a mistake in either of the two steps, or I should say 3 steps. You did some mistake in processing the data, or you have not distributed the train, test, and validate perfectly, or you have chosen the wrong model. For example, if you want to classify a dataset but you have chosen a regression model. So these are some mistakes that data scientists do, and they get a wrong result at the end and they frustrate a lot. But we will not be doing this in this playlist, and that's why I have created it, so that one should be able to know what is the best model for their data set, how to train it, how to validate it, how to test it, and how to make a good model. Okay. Knowing how to train the model, let's just know what are the types of machine learning models. So I'll just make a tree here, ML. Okay. So the very by the way, there are very many types of machine learning models, but we just specify it mainly in 3 types. The first is supervised. I'll tell you about it. Supervised. The second is supervised, unsupervised. Okay. The third one is reinforcement. I think I've written a uh, right spelling. I think I've written the right spelling. Okay. I'll not waste your time. Let's just make it quickly. Supervised is basically training the model by providing the labels. Okay. Uh, Step 1, you provide the data, obviously, but you also label the data. Labeling. What does labeling means? Labeling means that for like if we just take example of linear regression, of predicting salary based upon years of experience. So you just basically labeled it that there is a data set where I am having 2 features. One is obviously target is salary, and the other thing left, that is years. salary. Oh my god. It, so you labeled it already, that this column specifies salary, this column specify years of experience. So any type of learning where already labeled data is there. Okay, I'll tell you one more example. It's a very famous example that you'll get in every two other two videos of machine learning tutorials. Dog and cat. Obviously, you are provided with a data set of 1,000+ images of dogs and cats, but at every uh, image you label it. For example, this is the image of dog, so you label that image as a dog, you label this image as a cat. Okay, but after labeling you train the model. Okay, in very simple words, the machine already knows about the data you provide. Like if I tell you one more example, a very basic example, uh, like if we train a child on if we train a child or if we teach a child about alphabets A B C D, okay, so if I uh, provide him letters, I'm basically training it and providing the data that A B C D E F G H till Z. I am uh, training that child, but I am also telling him that these are all alphabets. Okay, na? These are all alphabets. I'm telling him or her. But if I write a letter in front of him like dollar or at the rate or hash, then he or she will obviously confuse, because I have not uh, provided them the information about these letters, that I only told them that A to Z or A to Z are those characters that fall under alphabets category. So this is called labeling, that I labeled these set of characters as alphabets, but I didn't label this, so that child will be unable to answer this question because he doesn't know what is this. So supervised learning does the same. It provides the data with labels so that machine do not confuse in future while testing the data. Okay, so uh, okay, let's just go let's check what are the popular supervised machine learning models. We'll go through scikit-learn. Okay, so let's just check what are the models that comes under supervised learning. So I'll just go on a very famous forum, or I should say website, scikit-learn. Scikit-learn is a library, obviously, and also it is basically the home of machine learning. Every machine learning model, their information, how to implement it, is written here. All the documents are there. Okay, so why I have provided you this, so that you can know about the actual definition and actual process behind the machine learning models. So supervised learning, we was checking supervised learning. So under supervised learning there are these type of different models. First is linear model. Linear model means that type of data that has a linear growth. Linear growth means okay, any type of data that is having a linear growth. That means if the data is like this, not like this, if the data is like this, the graph of the data, this is y-axis, obviously x-axis 0 coordinates, or like this, the intercept can be varying, but this type of visualization shows that data set is in a linear growth. Okay, so any data set that is in linear growth will apply linear models, and that comes under supervised. So but supervised, we provided a labeled set. Okay, so I'll also provide you this link, and you can go through these models, you can read this, but I'll not tell and go through every model because it will take a lot of time. It is very large forum. Okay, so let's just dive into the very first model. Okay, I'll tell you about the other types of machine learning model in further videos, because first we are learning supervised, then we'll go with unsupervised, then we'll go to reinforcement. Supervised first machine learning model is linear regression. This is the very basic and the very first and also very famous and also most used machine learning models in this world that exist till date. Okay, so I have a document, let's just learn from that document. Okay, okay, so let's just go to that document. Yeah, so the very first type was supervised, and the very first model is simple linear regression. First we'll go with the theory, and then we'll implement it using code, and we'll be coding it, and we'll be checking how it works, we'll be visualizing it, we'll be checking the real time. We'll be doing a very small real time project, not a project, but a small real time program. Okay, application basically. Yeah, so first we'll go with the definition. Simple linear regression is finding the best relationship between the input variable x. See, I told you, right? I told you x as dependent variable, but I also told you that you can change the variable. It's just the name. You can write anything. So x, that is independent here, and y, that is dependent. So it states that you have to find relationship between y and x. Y can be is the target, and x can be all those features that calculate the variable y or target y. Okay, so obviously it is a linear relationship. I told you what is linearity, what is a linear growth of a data set. Between these two variables can be represented as a straight line. Okay, I also told you that in machine learning, the target you want to predict or the target you want to calculate is a function. Without function you cannot predict values. Machine learning is not a thing where you imagine that computer is having a brain. Obviously it is having a brain, but it's not like that. Without mathematics it will predict values. So machine learning is all about maths. There is a function. So this function is for only simple linear regression. For every model there will be a different function. Like if I tell you an example of decision trees is also a machine learning model. So the the function for decision tree is this: gain equals to entropy p minus some n by n entropy I. So we'll be learning this in future videos, but today we are going through simple linear regression. So what do these terms represent now? Y is obviously target variable, x is the feature, b1 is the coefficient of x, and b0 is the intercept. We know about y. I told you it is a target variable. It is that feature which has to be predicted or which has to be calculated. X is a feature that is independent and is used to calculate the value of y. B1 is the coefficient of x. If you know about the basics of probability and statistics, then you should be knowing what is coefficient of x and also intercept. But don't worry if you don't know, I'll be visualizing it here so that it will be easy for you to understand. For example, there is a graph, okay, and the equation was y equals to, if I write it in very simple words, the equation was y equals to mx plus c. This was the equation in very simple words. I replaced b0 and b1, y-axis, x-axis, okay. So yeah, y was the target, we know this, x is the independent, we know this. With the help of probability and statistics formulas, we calculate m and c. Okay, so m is basically the slope of the graph for which the data is provided. For example, this is the linear growth of the dataset, of any dataset that is provided to you. So the slope will be m, and from the point it is starting will be intercept. For example, it is 0 and it is 1, and it is starting from 1, so the intercept will be 1. Now there will be a question that we know y, we know x also, but how to calculate the values of m and c? Okay, so in a data set, m is basically the sum of product of deviation, not this, sum of product of deviations divided by sum of square of deviations for x. So this is the value of m that has been calculated in, if we talk about theory of machine learning. Okay, we know m, x and y. Now how to calculate c? So c will be mean of y, and so in our case y is what was y? So in our case y is the target, so it was dependent, we have to calculate it. So intercept will be created mean of y divided minus m, that is slope, we calculate through the above formula multiplied by mean of x. So these are the two formulas. But do you know that every time you implement any machine learning model, do you write these formulas in program? No. So to implement this, we use a very popular library that I already told you is scikit-learn. Scikit-learn is a library that helps you to train, test, split, pre-process all those machine learning stuff with by just importing it. You'll be able to calculate c, you'll be able to calculate m, you will be visualizing this, we will be importing the model. We don't need to write this formula, it will be automatically created. Values of m and c will automatically be created. So let's just move further. We now know about these values. Now, yeah, sorry, what is deviation? I forgot to tell you. Deviation is basically the difference between those values, between actual and predicted values, between the actual value in the dataset and what the value is being predicted by this linear growth or by this slope. So that the difference between them, those values, is the deviation. Okay, moving further, the coefficients are estimated using least square Citroen criterion, that is the best fit line has to be calculated that minimizes the sum of square digits. Basically it is telling that how coefficients are calculated, but I already told you how it is done. Okay, so our very favorite part of the video comes here. Theory. I personally feel uh, reading theory is a little bit boring stuff, but one should know about the behind or backend process behind any machine learning model. So now let's dive into the coding part, how to implement simple linear regression model. So I have already opened a Jupyter notebook, or I can open it from the very scratch and write the code. So before going further, first let's import the necessary libraries. So the very first library is pandas. I want to import pandas as PD, where whenever I write as, I can write any name here, A, B, C or X, Y, Z, but it is convenient to write PD so that I can use pandas, or I can fetch objects of this library, class of this library using PD, not writing pandas every time. Similarly, numpy as np, and similarly cbond as sns. Similarly, matplotlib, import matplotlib.pyplot as plt. I think that's enough. Yeah, I'll tell you about these libraries, don't worry. Pandas is used to manipulate dataset. NumPy is used to play with arrays. It is a data structure basically. It is used to play with data structure. Cbond will be used in Cbond, and matplotlib will be used in visualizations. If I run this, no error, it is imported. Okay. So let's just first check our data set that we will be using. So the data set is salary data. Obviously I told you the very first example, we will be predicting salaries of person based on years of experience. Okay, before moving further, there is a doubt that might come in your mind, that what if the dataset is in categorical, sorry. That means that the target variable is in numbers, okay, but the features or the independent variable, what if they are in a category form? For example, I should show you rather than saying it. Yeah, I was talking about this type of data set. What if the data is in alphabets or characters, not in numbers? So this doesn't mean that we cannot apply linear regression model, or we have to use any other model. No. The very first step is, if the growth or if the relationship between target and independent variable in the data set is linear, okay, then you have to use linear regression model. It doesn't make an impact, or it doesn't matter that the value or data is in category form or is in number form, because if it is in number form, then it will be very easy for us to calculate MC, slope, intercept and all that values. But if it is in character form, then also it's not a big problem, because there is a term called encoding. Encodings will be used to convert these values into numbers, and then we will create a graph and we will train the model. Okay, coming back to our dataset. So this was our dataset. Let's just import this using our pandas. So I'll just denote a variable dataset. You can denote anything, x. Okay, so just let's denote it data. No, not data. Let's just denote it salary prediction data set. Okay, so using PD, because I imported pandas as PD, I will be reading the CSV file. What is the CSV file? I'll specify the path salary data.csv. Then I will be printing it, printing the head. Why use head? Head means printing only top first 5 rows. By default it prints first 5. If you write any number here, it will be printing the number of rows, top 6. For example, I have written 6. It will print top 6 rows of that data set that is imported. Let's just run it and see what it does. So 0 1 2 3 4 5. From 0 to 5, total number of rows is 6. If I enter 10 here, then 10 rows will be printed, and if I enter nothing, then by default 5 rows will be imported or will be shown. So that's how we import our data. That's how we see our data, select our data. Now, what was our first step? Our first step was pre-processing the data. The first step was importing. The second was pre-processing the data. We don't need to pre-process it because it is already in perfect form. There is no missing data, there is no irrelevant data, no redundant data. Everything looks perfectly fine here. If you want to check the data type also, so let's check the data type. Okay, salary prediction dot salary column. I think it's not like that. Yeah, salary data set, salary dot d type. I think that will work. Okay, so let's just see the data type also. If I want to see specific data type of a column, then I can use this thing. I'll type the name of the column, then d type. So let's just run it. So d type is integer form. 64 means it is a range, like 64 signed integers will be allowed to enter in this as a record. Okay, let's just also check salary years experience dot d type float. It is float. As you can see, it is in decimals, it is in float data type. If I want to see the data type of all the columns, so I think dot d types is the so the data set is object, salary is in integer, years of experience is in float 64. Let's move further. Let's see what is the next step. We imported the head. Okay, one more thing. To check the shape of your data set, our data set was in salary prediction data set. To check its shape means what is the dimension. So dimension is there is 30 rows and 2 columns. It will be always in the parameter of rows and columns. So there are 30 rows and 2 columns. Yeah, so our next step will be knowing like we know the function y equals to mx plus c is the function for linear regression. So one by one we should calculate the values of all those variables. So y, if we specify y as our independent variable, or let's see what he has. Let's see what y is here as. So y is salary, and salary is our dependent variable. Okay, so in this example, y is our target variable uh, also called dependent variable. So to assign the value of dependent variable from the dataset to this variable y, we will be using the dataset name, salary predictions, and then just write the column name you want. So salary as a column or a feature, or you can say it as a target, will be assigned to y, and x is our independent variable. Okay, one more thing. Here we know that there is only one feature, but what if there are more than one feature? So we'll just use drop function. Why drop? I'll tell you. It is saying that assign all values, all features to x except the salary column. It says that just remove the salary column, and whatever is left here will be all the features of x and y. If I run this, no error. Okay, perfectly fine. If I want to print it, let's just see that it is working or not. See, y is our salary column. It is printed here. These are the indexes. Don't worry, it is not any other column. These are indexes. Name, salary, dtype, and 64. This is years of experience. Okay. Yeah. So the next, we have calculated y and x. So the next step will be splitting. Obviously, I told you about splitting. So sklearn model helps us in splitting the dataset, no matter it is a supervised learning, unsupervised learning, reinforcement, or it is any type of data, categorical, decision trees, integers, numbers, float, everything. Also, if you have a data set of images, it will help. So we'll import sk learn dot data sets. I think sklearn dot data sets. We'll import train. Oh, model selections. It's model selection. Model selections import. From train test split. Yeah, let's just see if it's running or not. Yeah, no error, it's imported. So we will specify train and test distribution for both the variables x and y. So x train, x test, y train, and y test. Using train test split, we'll just split it. Our variables were x, y, and our test size will be 0.2. 0.2 means 20%. We also specify random state. Random state means it will be randomly distributing the values of train and test distribution. It can be any number, don't worry about this, that I have specified it for to do. It can be any number. It's just randomizing the distribution. So we have the splitted train test. Let's just run it. No error. If you want to check that how it is distributed, you can print their shapes. X dot shape, y train dot shape, y test dot shape. See, out of 30 rows, 24 rows were used for x train, 6 rows were used for x text, 24 rows were used for y train, and 6 rows were used for x text. This is the column. Okay. Now let's just visualize it, because we have chosen that we will be using linear regression model, but are we correct? That are we on a same path? Because if we train the model and afterwards it's not working as our expectation, that all our work will be just worthless or useless. What we did will be a waste of time. So visualization is most important, because if we are able to see that okay, the graph is in linear form, then linear regression will be a successful step in training the machine learning model for this dataset for predicting salaries based on years of experience. So remember, I imported Cbond as a library. So SNS has a function pair plot. What was our dataset? Our dataset was salary prediction dataset. Yeah. So SNS can be used to visualize the dataset. SNS pair plot helps to draw all those possible relation between the columns and visualize it. So for example, you can see years of experience and salary visualization is here. Years of experience and years of experience visualization is here. Salary and years of experience and salary. So if you can see these scatter plots here, so it clearly states that the data is in linear growth. Okay, so if it is in linear growth, then we can go further with this model, the so-called linear regression. So these things, plt.plot, yeah, it is used to basically plot the x train and y train relationship, so that we can check that have we splitted the dataset correctly and whether it is in linear growth or not. X train is not defined because x is in small. Yeah, so this is okay. This was the total dataset. This is the train dataset. If you want to see the test one, then you can also see the test one. Test yeah. So this is a test split was a small size. It was 20%. That's why the dots are very less in this scatter plot. Now let's go to our very crucial step, that is training the model. That was very important. We visualized it, we specified the y-x. Now we have to calculate m and c, so that we can use the slope or the graph to predict values. Again, sklearn helps us to calculate m and c values, slope and intercept values, and also train the model. So from sklearn, I am importing linear regression model. Linear regression model is one of the machine learning model, and sklearn helps you with that. No error, imported. We'll define a variable like trainer. Trainer will be an object for linear regression. Okay, linear regression. Now we'll fit the line, trainer.fit y-fit, because we have to split it the test. Now we just have to fit the slope in this graph. So using this line, it will automatically calculate m and c values, and it will fit a best line for the training and test splitted values. Fit on what? Fit on x train and y train. Let's just run it. It is fitted. Yeah. Now we'll be using predictions. Let's just check whether it will predict or not. So trainer. Before predicting value, I'll just run this line. So because I want to tell you something, let's just run this first. Predict what? Predict our x text split that we have used. X text round 1. If I print y print, so what are these values? X test was having 6 rows as the test split. So these are basically the predicted salaries for those years of experience. Okay, if you print X test, then you will be able to understand. Okay, so for years of experience of 9 years and 6 months, salary will be 1,15,000. 4 years and 9 months, salary will be 71,000. So these are the predicted values. If you want to predict custom value, then we have fitted the trainer as our slope. Trainer.predict you will use. Then just specify the years of experience. For example, 12 years. Why double braces? Because it is a 2D array. And if I pass the value in single braces, it will give an error. Let's just check it. Okay, vibrate. See, reshape error because it is not in the provided shape. See, for 12 years of experience, your predicted value is 1,38,000. For 1 years of experience, your salary will be 34,000. Okay, now we want to check, are these predicted values correct or not? So we can check the deviation, that what was the actual value and what is the predicted value. So to check the deviation, we'll visualize it. So this is the code to visualize and check the deviation. I'll explain it to you. Let's just first run it and check what is the X train is not defined. Yeah, sorry, X regressor is not defined. Yeah, it was trainer. Again X train. Okay, so this line was is created by us. We fit this, and these scatter plots is the actual values. So as you can see that the actual values are not too much deviated from the line that has been fitted for our predictions. So it's not that much wrong. Yeah, so to check the predicted values versus actual values, this is the code. Basically it is comparing that the y-test distribution versus what were the predicted values. So for the y-test, if the original salary was this, then predicted salary was not that much deviated. So I think our fit is not too much disturbed. It is in a good condition. So this much is all about linear regression, and we talked about what is machine learning model, we talked about how it works, we talked about types. We will be covering unsupervised and reinforcement further. We talked about linear regression, and in the future videos we'll be covering all supervised models, then unsupervised, then reinforcement models. So please, just if you like this video, please like it, subscribe my channel if you want to learn more about machine learning, and obviously I'll be posting videos. Please do comment and tell me that if I went wrong in between. So please specify the steps, and also please give me suggestions how I should deliver you the lecture if there was some mistake and you found that XYZ thing should be in other way. Please specify it in the comments. I will appreciate it. Thank you for watching. Goodbye.